Hi guys, I got a back titration question here. A group 2 carbonate was left in a bottle without a label. A 10-gram sample of this was mixed with 250 centimeters cubed of this molar HCl. The excess HCl had its volume increased to 500 centimeters cubed with distilled water and then portioned into 25 centimeter cube portions. These were titrated against this molar NaOH. It took 21 centimeters cubed of the NaOH to reach neutralization, identify the metal compound. I appreciate it's very wordy, so I'll try and piece together basically a story of what's happened. So you've got a carbonate that you don't know. And so a carbonate is going to look like M2 plus CO3 2 minus, where M is a metal. And so you've got 10 grams of that. You mix it with HCl. This will react. The HCl and the CO3 will react to form carbon dioxide, the metal ion, well, metal chloride, and water. So if I write that down here, we know that this reaction is going on. This is going to be 2 HCl, because if you look at it, this is Cl minus, and this is M2 plus. And this is going to form H2O, and then CO2, just like that. And also, sorry, MCl2, where M can be any group 2 carbon, any group 2 metal, sorry. So this is the first reaction that happens. But as you can see, the main bit about this is that this is the volume of HCl and it's excess. So we use too much HCl here, but this is useful because now that we know what the HCl is, we can work out the moles that have reacted. The way we can do this is by starting at the end. So we know it took 21 centimeters cubed of NaOH of this molar. So therefore we know the moles of NaOH are going to be equal to 0.2, which is the molar there, times by 0.021, which is this divided by 1,000. And this comes to be 0.0042 moles. And so now we know, because NaOH will react with HCl in a 1-to-1 ratio, we know HCl is also equal to 0.0042 moles. We know that every single one of these portions had 0.0042 moles in it, and they were 25 centimeters cubed portions, but they were total 500 centimeters cubed. So you have to do 0.0042 multiplied by 500 over 25, which will give you an answer of 0.084 moles that reacted with NaOH. And now we can see the total moles over here, I'll calculate it in a second, of the initial moles of HCl. And so the initial moles of HCl, I'm going to put HCl, was equal to 0.25, which is that divided by 1,000, multiplied by 1.5, which is equal to 0.375 moles. And so you do 0.375 minus the excess moles, 0.084, and this will give you an answer of 0.291 moles that reacted with MCO3. As we know from up here, the moles that reacted are double the moles of the metal carbonate, so we have to do 0.291 divided by 2 is equal to 0.1455 moles of the, well, basically of M, because it's a 1-to-1 ratio there. And so we know that, and therefore the MR is going to be equal to the mass divided by the number of moles. And so it's equal to 10 divided by 0.1455, which comes out to be 68.7 grams per mole. We're nearly there. I'm just going to move it up a little bit. If you know the carbonate, this is 12, and this together is 48. So together, the molar, basically the molar mass of that is 60 grams per mole. And so you take off 60 because you're basically getting rid of the carbonate here. You just want to find out what the metal is. Take off 60, and that gives an answer of 8.7, which is basically beryllium. It's very close to it. Beryllium is 9. So therefore you can say with confidence the carbonate is beryllium carbonate.